In this lesson, we're going to talk about particle motion. So we have a chart here that we're going to go through. On the left, it says the expression, and on the right is the mathematical translation. First, we have initial position, initial velocity, or initial acceleration of a particle, and that means that time is going to be equal to 0. Next, we have particle is a position s at time t, and it says this gives us the position of the particle at a specific time, s of t, where again, s is usually the variable used for position, v is for velocity, and a for acceleration. When a particle is at rest, this means that the velocity is 0, or v of t equals 0. When a particle is moving to the right, remember velocity indicates direction. So when your particle is moving to the right, that means your velocity is positive, or we would say v of t is greater than 0. Given the context of a problem, a particle could also be moving up or forward, and same thing, velocity would be positive or v of t would be greater than 0. Next we have a particle is moving to the left, and again, it also could be down or backwards, and for any of those, that means velocity is negative or v of t is less than 0. For average velocity of the particle on the closed interval from a to b, you have your average value formula. It's 1 over b minus a, the integral from a to b of v of t dt. If you integrate velocity, that gives you position. Again, position is indicated by s. And you evaluate from a to b, so we plug in b minus plugging in a, and you get s of b minus s of a, all divided by quantity b minus a. So again, this is average velocity, or you could use this formula for average velocity. Next, we have instantaneous velocity of the particle at time t. So your velocity, or v of t, is equal to the derivative of the position function, or s prime of t. For acceleration of the particle at time t, we have a of t acceleration, which equals the derivative of velocity, or the second derivative of the position function. Here we have the velocity of the particle is increasing. That means that the derivative of the velocity is positive, or the acceleration, which equals the derivative of velocity, is greater than 0. Next, if the velocity of the particle is decreasing, that means the derivative of velocity is negative, or a of t, which equals the derivative of velocity, is less than 0. The speed of the particle is going to be the absolute value of velocity. So you just take the absolute value of your velocity function. Here we have the speed of the particle is increasing, or the particle is speeding up. That means that velocity and acceleration have the same sign. So either the velocity is positive and the acceleration is positive, or velocity is negative and also the acceleration is negative. Next we have the speed of the particle is decreasing, or the particle is slowing down. That means that velocity and acceleration have different signs. So if your velocity is positive, that means acceleration is negative. Or vice versa, if velocity is negative, that means acceleration is positive. To find the total distance traveled by the particle over the closed interval from a to b, you're calculating the integral from a to b of the absolute value of velocity. To find the displacement of the particle, or the net distance traveled by the particle over the time interval from a to b, it's the integral from a to b of v of t dt. Oftentimes you're going to need the position of a particle at a given time t, and sometimes we're going to need to find the position of the particle at a given time t sub 2, and we're going to be given the position at a different time t sub 1. So to find the position at s of t sub 2, it equals the position at t sub 1 plus the integral from t sub 1 to t sub 2 of the velocity function. Next, if you need to find where the particle changes direction, this occurs where the velocity of the particle changes from positive to negative or from negative to positive. So to figure out where the particle changes direction, you would take the velocity and set it equal to 0 to find where the particle is at rest. Then you would put that on a number line, and you can test values around that value to figure out where velocity is positive versus negative, and then anytime velocity changes from positive to negative or vice versa, that's where the particle changes direction. And finally, to find where the particle is farthest to the left or right, what you do is you find the minimum or maximum value of the position function over an interval. Then you find the values of t, where s prime of t or v of t equals 0, which are the critical points of s, the position, and then you consider the position of the particle at the critical points, and if the interval is closed, also at the endpoints of the interval. And that will give you the maximum and minimum values of the position function on that interval, indicating where the particle is farthest to the left or the right. This example says, for 0 less than or equal to t less than or equal to 10, a particle moves along a horizontal line. The velocity of the particle at time t is given by v of t equals t squared minus 9t plus 14. The particle is at a position of 15 at the time that t equals 0. Part A says, for the closed interval from 0 to 10, when is the particle moving to the left? So first we need to find when the particle is at rest. So that means we're going to take the velocity, we're going to set it equal to 0, and we're going to solve. So we're going to factor this. So we get t minus 2 times t minus 7. Set them both equal to 0, and we get 2 and 7. Next, we put these numbers on a number line for velocity, and we're going to test the values around them. So I just arbitrarily picked 1, so we're going to do v of 1. In between 2 and 7, I just chose 3, so we're going to find v of 3. And then I chose 8, so we'll find the velocity at 8 seconds. When we take 1, we can use this formula for velocity, or we can use the factored form. I'm going to use the factored form because it might be a little bit quicker. When we plug in 1 for t, we get -1 here, and we get -6 here. So -1 times -6 is positive 6. When we plug 3 in for t, we get 1, and 3 right here makes -4, so we end up getting -4. When we plug in 8 for t, we get 6, and then over here we get 1, so that makes 6. And the particle is moving to the left when the velocity is negative, so you can see that that occurs right here between 2 and 7. So I wrote it out. The particle is moving to the left when the velocity is less than 0, and this occurs when t is between 2 and 7. Part B says find the total distance traveled by the particle from time t equals 0 to time t equals 4. Alright, the first thing we want to note is velocity is equal to 0, meaning the particle is at rest at t equals 2 and 7. For this part of the problem, we're only concerned when t is between 0 and 4. We're just going to use t equals 2. So what we're going to do is we're given velocity and we need the position function. In order to find the position function from velocity, we're going to integrate or take the antiderivative. So we get 1/3 t cubed minus 9/2 t squared plus 14t. And normally we would put a plus c at the end, but since we're about to plug in 2 here and then 0 here, and then subtract them from each other, we don't need an arbitrary constant because you would be subtracting it from itself anyways. So to find our total distance traveled from 0 to 4 seconds, remember the particle stopped at t equals 2 seconds. So we're calculating the distance the particle traveled from 0 to 2, and then we're adding the distance the particle traveled from 2 to 4 seconds. So this is going to represent the distance the particle travels from 0 to 2 seconds, and then we add to that the distance the particle travels from 2 to 4 seconds. So I'm going to plug 2 into our position function right here, and then I plugged 0 into this, but you just get 0. Next I'm going to plug 4 into this, and then we're plugging 2 into this again. Okay, so now we're going to simplify. Alright, so when you finish simplifying, you get that the total distance traveled by the particle from time t equals 0 to 4 is 20. Find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at t equals 3? Explain your reasoning. So here's our velocity function. To find acceleration, we're going to take the derivative. So we get that acceleration is 2t minus 9. To find whether the speed of the particle is increasing, decreasing, or neither at t equals 3, we want to create a sign chart to figure out where the signs of these are the same or where they are opposite. We already created a sign chart for velocity in part A, so now we just need to create one for acceleration. So first thing, we're going to set this equal to 0 and solve. So we get the critical value that t is equal to 9/2, or 4.5. So we put 4.5 on a sign chart for acceleration, and now we're going to plug in values around 4.5. When we plug in 1 right here, we get -7, so this interval acceleration is negative. When we plug in 5 right here, we get 1, so to the right of 4.5, acceleration is positive. So we want to look at when t equals 3. So I marked 3 on these sign charts. You can see at t equals 3, velocity is negative. And then down here you can see at t equals 3, acceleration is also negative. So they have the same sign, indicating that the speed of the particle is going to be increasing. So I wrote that out. At t equals 3, velocity and acceleration have the same sign, therefore the speed of the particle is increasing. Part D says find the position of the particle when t is 8. And then I made a note over here, the initial condition that they give us is the position at t equals 0 equals 15. So to set this up, we're trying to find the position when t is 8, and we know the position when t is 0. So we set it up as s of 0 plus the integral from 0 to 8 of the velocity function. So I plugged in 15, and then I wrote in the formula for velocity. So we integrate, and we get this for our position function. Now we're going to plug in 8 minus plugging in 0. When we plug in 8 here, we get 512 over 3. When we plug in 8 here, we get -288. And then here, 8 times 14 is 112. And then when we simplify this, we get the position of the particle when t equals 8 is 29 over 3. Alright guys, thanks so much for watching!